In this video, we are going to learn how to find the range of a function. So in general, it's actually quite hard to find the range, but there are two special situations where we can quickly solve for it. So the first method is if we know the graph, or we can graph it pretty quickly, we can use the graph to determine the actual y values we achieve. So let's get into an example. Let's say I want to find the domain and the range of this function. So first off, for my domain, I'm trying to think about what x can be. And when I look at this function, well, I don't see any restrictions. Like there's nothing I can plug in that would make a denominator 0. There's no even roots here, so I don't have to worry about that making anything undefined. So my domain is going to be everything. In interval notation, that's negative infinity to positive infinity. That's my domain. For my range, I want to notice that, well, this is a quadratic. And the leading coefficient's positive, so it's going to be some sort of upward parabola. I just need to know like how high up or how low the parabola is so I can figure out where the vertex is. And knowing that will tell me where the y values are going to be. We can find the vertex by completing the square. In fact, I've written up all the steps of completing the square here, and I want to leave it to you at this point to pause for about 2 minutes to look through all those steps and make sure you understand how we did all of those. So pause it in 3, 2, 1, pause it and look through those completing the square steps. Okay, so hopefully you did that. If you didn't, definitely do that. This is really, really important to make sure you understand the steps of completing the square. But I'm going to highlight here the vertex form. I can use this now to write down my vertex. So my vertex, the x coordinate is what I plug in for x to make this parentheses be 0. That's negative 8. And if I do plug that in, then y is going to be equal to, this part becomes 0, and I'll get 0 minus 6, which is negative 6. So I got my vertex. I'm going to label that in my graph. So negative 8, negative 6 is somewhere here. And, now if I want to draw a slightly more accurate picture, I could find intercepts. Just for practice, I'll find the y-intercept. To find my y-intercept, we set x equal to 0. So if I set x equal to 0 in this original equation, well, these first two terms just become 0, and you'll get y equals 10. You'll get y equals 10. So my y-intercept is at the point 0, 10. And now if I draw my parabola, so at the vertex goes upwards through that y-intercept, and then it kind of mirrors that, going this way. So something like this. So my smallest y value is at the vertex, that's negative 6. And then I hit every single y value going up from there. So my range starts at negative 6. I'll put a bracket there. And then it goes onwards to infinity. And we got it. So that is our domain and range. So for any graph for any function where I can graph it quickly, I can use that graph to find my range. All right. So what's the other method? If I don't know the graph, we can try isolating for x. We're not always able to do that. It turns out that in order to be able to do that, it'll typically require that my function has what's called an inverse, and we'll learn more about that in a later section. But let's get into an example. So let's say I want to find the domain and the range of this fractional function. So this isn't something that we've learned how to graph yet in our class. So I'm going to start off by finding the domain. For the domain of this, I do see a restriction. So I do see a restriction because there's the denominator. So the thing in the denominator, I'm going to number my restriction, is 2x plus 5. That needs to not be equal to 0. And if we isolate the x in this, I'll get that x is not equal to negative 5 over 2. Right? If I subtract the 5 and then I divide the 2. So x can be anything except for negative 5 over 2. So in interval notation, my domain is negative infinity to negative 5 over 2, parentheses, because it's not included, union negative 5 over 2, onwards to infinity. Okay, and that's my domain. All right, and now for the range, we're going to use this new method. I'm first going to just relabel f of x as y, and now I'm going to try to isolate for x. So first, to get rid of this fraction, let's multiply both sides by that denominator. 2x plus 5. So multiplying both sides by that denominator. And now on the right side, well, this 2x plus 5 on the bottom, that can get canceled by this 2x plus 5 on the top. So it'll leave me with 1s in those spots. And then if I distribute the y in to the left-hand side, I'll get 2xy plus 5y equals, on the right, I got 4x minus 15. So now I want to move all the terms that have an x to one side. So this term has an x, this term has an x. Let's move the 4x maybe over here, and then I'll move the 5y to the right. So that's going to give me 2xy minus 4x equals negative 5y minus 15. So on the left side, I notice that x is common to both of these terms, so I can factor that out. So I'll factor out an x, and that leaves me with 2y minus 4 equals, on the right, negative 5y minus 15. And now the stuff in parentheses, I can divide it over to the other side. So that leaves me with x on the left equals negative 5y minus 15 getting divided by 2y minus 4. And now so the x is isolated and it's in terms of y. So to find the range, to find the possible y values, I'm going to think about, well, what are the restrictions on y in this setup? So what are the restrictions on y? Restrictions on y. Well, I see one restriction, because there's a denominator. That denominator, 2y minus 4, better not be equal to 0. And if we rearrange this, if we move the 4 over and then we divide the 2, we'll get that, well, y better not be equal to 2. So the range is, y could be anything except for 2. And in interval notation, I can write my range, and we get negative infinity to 2, not included, union 2 to infinity. Okay, and there we got it. So that is how we can find the range if we don't know the graph and we can isolate x in the way that we did here.